In this video, we'll consider the orthogonality condition. We'll find the area of a triangle formed by the given two vectors and the volume of a pyramid constructed on three given vectors, and we'll find the angle between two vectors. In the example number 8, we have to find the number n, which is the first coordinate of the given vector b. And we know that vectors a and b are orthogonal. What does it mean? It means that the dot product of the given vectors is 0. How to find the dot product of two vectors if we know the coordinates of that vectors? It is the sum of products of the corresponding coordinates. 2 multiplied by n, it is the product of the first coordinates, plus 4 multiplied by 1, it is the product of the second coordinates, plus 1 multiplied by minus 8, the third coordinates, and it must be 0. So we have the equation with unknown n. 2n plus 4 minus 8 equals 0. 2n plus 4 minus 8, it is minus 4. From here, 2n equals 4, and to find n, what we should do, 4 divided by 2. It's our answer. N equals 2. We have two vectors, a and b, and we must find the area of triangle formed by that vectors. Let's consider the given vectors when their initial point is the same. Look, it's my vector a and it's my vector b, the same initial point, and the triangle formed by that vectors. How to find the area of that triangle? The area of the triangle formed by the vectors a and b, it is 1 over 2 multiplied by the absolute value of the cross product of the given vectors. At first, let's find the cross product of the vectors a and b. We know the coordinates of the given vectors, so it will be the determinant of the third order. In the first row, standard unit vectors I, j, k. In the second row, the coordinates of the first vector a, minus 1, 2, minus 2, and in the third row, the coordinates of the vector b, 2, 1, and minus 1. Our determinant equals to the elements of the first row I, j, k multiplied by their cofactors. Look, the cofactor of the first element, it is minus 1 to the power the first row and the first column, so 1 plus 1 multiplied by minor of the element I, it is 2 minus 2, 1 minus 1, determinant of the second order, plus j, the second element j we should multiply it by minus 1 to the power 1 plus 2, the first row and the second column, 1 plus 2, multiplied by their minor, minus 1, 2, minus 2, minus 1, plus the third element k. Look, it will be minus 1 to the power the first row and the third column, 1 plus 3, multiplied by their minor, minus 1, 2, 2, 1. So we have minus 1 to the second power, it is plus 1, minus 1 to the power 3, it is minus 1, and here we have minus 1 to the power 4, it is plus 1. So we'll have I multiplied by 1 and multiplied by the determinant of the second order. We should multiply the elements of the main diagonal. 2 multiplied by minus 1, it is minus 2, minus the product of the elements of the second diagonal. It is minus 2 multiplied by 1, it is minus 2. Then plus j multiplied by minus 1, we'll have minus j, and we should solve the determinant of the second order. It is minus 1 multiplied by minus 1, it is 1, minus 2 multiplied by minus 2, minus 4, minus 4, so plus 4. Then plus k, vector k multiplied by 1 and multiplied by the determinant of the second order. Minus 1 by minus 1, minus 1, minus 2 by 2, minus 4. So we have I multiplied by minus 2 plus 2, it is 0, multiplied by 0. Then minus j multiplied by 5, and plus k, vector k multiplied by minus 5. So we have 0 multiplied by vector I, minus 5 multiplied by j, and minus 5 multiplied by k. So our cross product, it is the vector with the coordinates 0, minus 5, and minus 5. It is the vector with that coordinates. It's the cross product of the given vectors a and b. And now we'll find the absolute value of the cross product. It is the square root of the sum of squares of the coordinates of that vector. So 0 squared plus minus 5 squared plus minus 5 squared. We have minus 5 squared, 25, plus 25 square root of 50, and 50, it is 25 multiplied by 2, and square root of 25, it is 5, and we'll have 5 square root of 2. So the area of the given triangle equals to 1 over 2 multiplied by 5 square root of 2. 5 divided by 2, it will be 2.5 multiplied by square root of 2. It's our answer. Let's consider the vectors a, b, c when their initial point is the same. So vector a, vector b, and vector c. And we must find the volume of a pyramid constructed on the given vectors. The pyramid constructed by the given vectors. The volume of the pyramid constructed on the given vectors a, b, and c, it is 1 over 6 multiplied by the absolute value of the triple scalar product of the vectors a, b, and c. How to find the triple scalar product of the vectors? It is determinant of the third order. In the first row, the coordinates of the first vector, the second row, the coordinates of the second vector, and the third row, the coordinates of the third vector. One of the rules to calculate the determinant of the third order is Look, I'll rewrite the elements of the first and of the second row. Then let's consider the main diagonal and parallel lines, two parallel lines. The product of the elements of the main diagonal, 1 minus 3, 5, plus the next triple, 2, 4, minus 1, 2, 4, minus 1, plus minus 1, 1, 0, plus minus 1 multiplied by 1 multiplied by 0. Then we'll consider the second diagonal and we'll take that product with minus. So minus 1 multiplied by minus 3 multiplied by minus 1. And the next triple will be with minus 0, 4, 1, 0, 4, 1, and minus the third triple of numbers, 5, 1, 2, 5, 1, 2. That's all. Let's calculate it. So we'll have minus 15 minus 8, then it is 0, then 4 minuses. So we'll have plus here plus 3, 0, and minus 10. So we'll have minus 15, here minus 7 and minus 8. Minus 15, we'll have minus 30. Look, our triple scalar product is negative number. What does it mean? It means that the given vectors A, B, and C form the left-handed triple, but the volume of the pyramid, it is 1 over 6 multiplied by absolute value of the number minus 30. It will be plus 30 divided by 6. It is 5. Our answer, the volume of a pyramid constructed on the given vectors, is 5. I, J, K are standard unit vectors. So we have expression of the vector A in the form of standard unit vectors. Vector I with the coefficient 1, but the second vector J will be with the coefficient 0, plus 0 multiplied by J, and plus minus 1 multiplied by the vector K. So we have the vector A with the coordinates 1, 0, minus 1. Vector B, it is vector I with coefficient 0 plus vector G with coefficient minus 1 and vector K with coefficient 1. Vector B with the coordinates 0, minus 1, 1. The cosine of the angle between vectors A and B, angle alpha, it is the scalar product of the vectors A and B, or in other words, it's dot product of the vectors A and B, divided by the product of their absolute values, the product of their lengths. The dot product of the vectors A and B, it is the sum of products of their corresponding coordinates. The first coordinates, 1 multiplied by 0, plus the second coordinates, 0 multiplied by minus 1, and plus the third coordinates, minus 1 multiplied by 1. So we have 0 plus 0 minus 1. And the length of the vector A, or absolute value of the vector A, it is the square root of the sum of products of their coordinates, 1 squared plus 0 squared plus minus 1 squared. So we have 1 plus 1, it is 2, square root of 2. And the length of the vector B, it is square root of the sum of squares of their coordinates, minus 1 and 1. So we have the same, square root of 2. Now, cosine of the angle alpha between the given vectors, it is minus 1 in the numerator and square root of 2 multiplied by square root of 2 in the denominator. So we have minus 1 over 2. The cosine of the angle alpha is negative. What does it mean? It means that the angle alpha is obtuse angle, so it is greater than 90 degrees. So the angle between the given vectors A and B is obtuse angle. The angle alpha is arc cosine of the number minus 1 over 2, and it is pi minus arc cosine of 1 over 2. We know that cosine of pi over 3 is 1 over 2. So arc cosine of 1 over 2, it is pi over 3. So we have pi minus pi over 3, or 3 pi over 3 minus pi over 3. It will be 3 pi minus pi, it is 2 pi over 3. It's our answer. The angle between two given vectors, 2 pi over 3.